Hello, everyone. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conquin, New York, and there's my email address. We're on Unit 6. We're doing pages 29 to 32. This is Lesson 8, and this is Part B, or Part 2. Okay, go back and watch Part 1. Now, Part 1 is a PowerPoint presentation, so it's animated. It's not part of this book. If you don't understand what I'm saying, you can scan this QR code and listen to a different teacher's perspective on it, the person that wrote these worksheets. So let's go. This says completing the square, and as I said in the previous lesson, we're not completing the square. This is the first several steps of completing the square, but we're putting in vertex form to shift the parabolas. Okay, so parabolas and graphs, more generally, can be moved horizontally and vertically by some simple manipulations of their equations. Well, it's not by manipulations of equations, but you can instantaneously see where the vertex is going to be after you manipulate the equation. This is known as a shift or a translation of a graph. You should work with this extensively in Common Core Algebra 1. Remember, a couple of years ago. The first exercise will review how the method of completing the square to identify the shifts. Okay, so we're going to do vertex form. We're going to stop at the vertex form. We're not going to do the several more steps to complete the square. Okay. So here, this is what I call the mother function, y equals x squared. Why is it the mother function? Because it gives birth to all the other parabolas. By knowing that that is on the origin, we know how to shift all of the others. Now, here's an equation of another quadratic. That's not the mother function. Using the method of vertex, write this equation in the form. Okay, there it is. Now, there are several different ways that we can write this equation. Later on in the book, you're going to see another way. But the way that I prefer is having that x plus h quantity squared plus k. Okay, so change that to a plus. Change to addition. Okay. So the first thing that we did when we watched the video yesterday is the fact that, okay, the number in front has to be a 1. It is. Then we take half of b. b is the negative 8. So that's negative 4. And then we square it. Okay. So half of b squared is 16. We're going to have to use those numbers. Okay, so I'm going to write down 0 equals x squared minus 8x plus 18. We're going to move the 18 over, and we have negative 18 equals x squared minus 8x. Now, they didn't give us enough room. Let me write smaller. This is why I like to think about this as attaching it to completing the square, because we got to use the square number, the 16 number, completing the square. So we have to add 16 to both sides. So we have negative 2 equals x squared minus 8x plus 16. Guess what? This factors. What factors? Pointing to it. I can't see it pointing to it. Well, here I am. This factors. This factors. Not that. This factors. So let's factor it. And it factors very easily. Negative 2 equals. Now, why in the world did Mr. Bryce write down half of b? Because that's the key to factoring. X minus 4 squared. Bingo. It is now factored. Hang on, Mr. Bryce, you said that this has to look like this equation. There's a plus k, and that's just a y. It can't be a number like negative 2. Okay, so let's bring her home. So if we start with negative 2 equals x minus 4 squared, let's move the negative 2 over by adding 2. We have 0 equals x minus 4 quantity squared plus 2. Wait, I want the whole graph. I don't want to know where it intercepts the x-axis. I want the whole graph. So there's the whole graph. Y equals x minus 4 quantity squared plus 2. Hang on, you're contradicting yourself all the time. Before, Mr. Bryce, you said that you like the plus version. Yes, I like the plus version. And we are going to find out right here for question number B. Question B. Describe how the graph of y equals x squared would be shifted to produce this graph of the one that we just put into what form? What form? Vertex form. So y equals x minus 4 squared plus 2. Here, opposite, opposite. Here, same. Okay, this is left and right. This is up and down. Okay, the same. So that means it went up 2, opposite, negative 4. So that means to the right, 4. Wow. Okay, listen to that one more time or ask me some questions because that is key to this whole vertex form part where we have to, what are we doing? We're shifting it to the opposite direction. This looks like negative 4. Looks like we're moving it to the left. No, we're not. We're moving it to the right 4. Looks like we're going to, yep, positive 2, same direction. So you move it up. So here's the vertex, and it says move it to the right 4. 1, 2, 3, 4. Move it up 2. 1, 2. There's the new vertex, and we can sketch the parabola kind of like that. I just sketched it. That's a sketch. Why? Because I didn't take the exact points. Woohoo! We're having fun now. We sketched it. Now by using it in vertex form, right there, what are the coordinates of its turning point, of the vertex? Well, let me see. I said that we're going to move it to the right 4. That's the x direction 4, and we're going to move it up 2. There we go. You can check on the graph. A 1, a 2, a 3, a 4, an up 1, an up 2. There it is. Okay, now let's use our pencil eraser. There we go. Exercise 2. Let's see if I really want to use the calculator. I've got something special for us. So we're going to do x squared, 3x squared, and a half x squared. So when we take a look at this, okay, let me turn it into x squared. There, that's what the parabola looks like when it's x squared. Now, let's take a look at what it looks like when it's 2x squared. Wait, what happened there? See that? Okay, there's 1x, there's 2x, there's 1x, there's 2x, there's 3x, there's 4x. What's happening? It's getting skinnier. There it is. And then, so it got, sorry, you can't have a 0 there. So there's 1x, there's 2x. It became thinner. So it says sketch them. Okay, so we're just going to sketch one of them. We're going to sketch the x squared. Why are we sketching y equals x squared? Because that's the what kind of function? That's the mother function. Okay, and label it y equals x squared. Okay, it does say y, it doesn't say f of x. Now, 3x squared, that's going to be skinnier. Don't put that little blip in there. Okay, don't forget the arrows at the end. And that one is y equals 3x squared. And then the last one is 1/2 x squared. Wonder what's going to happen there. Oh, that's going to be wider. Now, why is this happening? It's really very simple when you think about it. What's happening is with the y, that's my answer. My answer is standard. It's what it's going to be. It's regular. It's, a size, 10 shoe. I don't know, it's a 42 sport coat. Okay? It's a regular sporting coat. Okay? Now, what happens with y equals 3x? Y equals, oh my goodness, 3x squared. We're going to have this, we're going to take my normal answer. We're going to take my normal answer here. We're going to make it 3 times bigger. So it's going to get faster. It's going to really zip up there. Okay, instead of being the 0.11, it's going to be the 0.13. Instead of being the 0.24, it's going to be 2.8. Okay, so obviously that's not drawn to scale. It's just sketched. And then here, we're going to move slower. We're going to take my answer, we're going to take half of it. So that's kind of the rate of change. That's kind of like a slope. On the next page, it says the algorithm or the process of completing the square works best when a is 1. Works best, he's even saying it, works best when a equals 1 and b is even, an even number, in the form y equals ax squared plus bx plus c. But it does work in every case, even the messy ones, even when a is not 1. Oh, wait, you know what I'm going to do? I'm going to make a 1. I'm going to force it to be 1. How? There is a right there. That's a. Just divide by 3. Divide everything by 3. So y equals x squared plus 4x minus 2/3. Okay? And now place each of the following quadratic functions in vertex form and identify the turning point. So what do I want to know? What do I want to know to put it into vertex form? I want to know that b is positive 4. And I want to know what half of b is squared. Half of b squared, let me see, half of b is 2, and 2 squared is 4. Now, I can move that 2/3 to the left-hand side. So why don't I do that? I'm going to add 2/3, and I get 2/3 equals x squared plus 4x. Now I'm going to complete the square. I'm going to add 4 to both sides. I'm going to add 4 to both sides. And you know what? You're like, why are you moving this to left and right? Hey, I just am. So 4 and 2/3. What? Yes, 4 plus 2/3 is 4 and 2/3. Equals x squared plus 4x plus 4. Now, I remember I just said that we can factor this part here by just taking a look at what half of b is. Half of b is 2. Okay, so this factors to be 4 and 2/3 equals quantity x plus 2 closed squared. Now let's move the 4 and 2/3 to the other side because we need it in this form. We need it in this form down here. So I'm going to subtract the 4 and 2/3, and I get y equals, or x, or 0 equals, it doesn't matter. We'll have to turn into a y equals anyway. X plus 2 squared minus 4 and 2/3. There we go. Now it says state the vertex. Remember, we're moving the opposite. We're going to move -2 in the x direction, -2 in the x direction. So the vertex is -2. We move in the same direction as here. This is -4 and 2/3. So it's -4 and 2/3. That's the vertex. Okay, let's see if we can do this one really quick. The first thing I'm going to do is subtract a nope. Mr. Bryce, the first thing I'm going to do is divide everything by 2. So when I divide everything by 2, I get x squared plus 3x, beautiful, it's not an even number, plus a half equals y. I'm going to move the half over, x squared plus 3x equals -1/2. Now, I'm going to squeeze up here the fact that b is 3, half of b is 1.5, and half of b squared is 2.25. So now I This is called completing the square vertex form. Completing the square vertex form. So I take the square, and add it to both sides. When I add 2.25 to negative 1/2, I get positive 1.75. Now, this factors very easily to be half of b. I love half of b squared equals 1.75. Now let's put it into vertex form right here. We have x plus 1.5 quantity squared. Subtract 1.75 from both sides. Subtract 1.75 from both sides. And I'm going to make that equal to y instead of equal to 0 because we want to have the whole equation. We want to look at the whole parabola. Okay, I'm kind of getting away from myself. Here we go. So what is the vertex? The vertex is opposite the x direction, so it's negative 1.5 comma same direction as that, so it's negative 1.75. Bingo, you can never see that on a graph. Well, okay, I showed you how to do it on a graph, but if you don't have your graphing calculator, you can't see that on the graph. In the old days when we had to draw them, you couldn't see that from the drawing. Your graphing calculator is smarter than the picture, and it tells you exactly where it is. Let's look at the next question. So our buddy here said that the method of completing the square can be performed in a standard quadratic equation, y equals ax squared plus bx plus c, after much manipulation, and can be placed in that form right there. Okay, now I covered it up. We're not crossing it off. We're just writing mine next to it because I really like mine. But this is special. That part right there is special. And we're going to see down below in exercise number 5. Okay, so based on this formula, which formula? My formula. What's the x-coordinate of the turning point of any parabola? Be careful. Okay, I said it's going to be the opposite of h. It's going to be the opposite of h. So that's positive h, so it's going to be negative h. And it's going to be the same as the k number. Same as the k number. Woo! Slam dunk. Use this formula to find which formula? My formula. Well, okay, it's really not mine, but the one that I use all the time to find the turning point of that one. Okay, first of all, we realize that right there, A is already 1. Whew, good. So let's add 2 to both sides. And we get 2, because remember, I'm going to change that. I shouldn't write an x there. I'm going to change that to a 0. We add 2 to both sides, and we get x squared plus 10x. Now, B is 10. Half of B is 5, and half of B squared is 25. Now, why am I putting in parentheses and squaring it? I'm putting it there because, you know, those negatives are tricky. So always put your squares in parentheses. There we go. Now, I add, this is called completing the square vertex form, completing the square vertex form. So I add 25 because that's the square. That's half of B squared. I add 25 to both sides. And I get 27 equals x squared. Wow, the orientation is off on this. So there we go. The equation is 27 equals x squared plus 10x plus 25. I still love the half of b part because I can now factor this into x plus 5 squared. Now we want it in vertex form, so let's get rid of the 27, and we want the whole parabola. So it's y equals x plus 5 quantity squared minus 27. Okay, this is mental arithmetic that we can do. And it says find the turning point. There it is right there. No, okay, remember, write it down. Opposite of the thing inside the parentheses, so it's negative 5. Same as what's outside the parentheses, so it's 27. There we go. And what are we going to do? We're going to skip because this is the method that I like. We already did it. Verify both examples by looking at the table on your calculator and the order. Mr. Bryce, you said that we had to solve this algebraically. We can't do it graphically. Well, you can always check graphically. So I typed the equation into the graphing calculator. I hit second table. Bingo, bango, bongo. There is our table. Okay, so here's our table. And what do we know about the turning point? We know the fact that the turning point is going to be symmetrical. We have negative 2's there. we have 11s there, we have 18s there, we have 23s there, we have 26, symmetrical. There we go, -5, -27. It checks. I know you can't write down that table onto, the whole thing that big on the calculator, but you can write it right there. XY, rewind it if you didn't write down the numbers. Now, this is what I said earlier for example number 5. His equation right here is nice for example number 5. Use the formula x equals -b over 2a to find the turning points for each of the following quadratic functions. The turning point. Okay, this is also called the line of symmetry, okay? The line of symmetry. So that's the line of symmetry. So let me see. All we have to do is find out what B is, find out what A is. So there's A right there, and there's B right there. So x equals B, which is -12. I said -12 all over 2A. That's 2 times 2. So what I like to do is I like to flip the negative sign up onto the numerator. So it's -12. Let me see. What is -12? Oh, yeah, it's 12. And 2 times 2 is 4. Okay, so there we go. There is the x coordinate of this equation. Now, what do you mean that's the x coordinate? Well, it's 3. Now, how can I find the y coordinate? Plug it back into the equation. What are you talking about it? I'm talking about it is x. So I plugged 3 in everywhere that was next, hit equals, and I got -11 for our y coordinate. So it's 3, -11. Zimba, we got it. Now, let's do the same thing here. I just care what A is. A is -1/4, and B is 5. Okay, wait, I thought you just said I just care what A is. Well, I also care what B is. I just was not getting ahead of myself. So now I plug it in. X equals -B, -5, all over 2 times A, all over 2 times -1/4. That is -5 times -1/2, or divided by -1/2, which happens to be 10. What? You're nuts. No. Let's find out together. So I did 5, -5, okay. -5 divided by -1/2. You put the fraction in parentheses, and we get +10. So now, that's the x part of the coordinate. Silly me. That's the x part of the coordinate. Now we have to find the y just by plugging it in there. And we get 5. And we're done. Okay, ladies and gentlemen, so if you're having problems with this, make sure you ask me lots of questions in class, ask us during study halls, any free time. Just ask me for help. If you really want to, you can either go back to the original guy who did this worksheet and listen to his QR reader, or listen to me again. Ladies and gentlemen, you know what the homework is. The homework, or the assignment that you have to do next, are the next 2 pages. Okay, because you're like, well, I'm not at home. I happen to be over at a friend's house, so I can't do homework. Hey, no excuses. Just get the next 2 pages done. See ya.